Okay. Okay. So the meeting is being recorded and it is also being streamed. Okay, so I hope my screen is visible.
Yes, Malo.
Right. So last week I had promised that I would be doing a primal dual formulation. So what I will do is, this is the problem that I'm going to solve. Okay. I'll just leave that on the screen. Okay. So this is the problem that that we'll be solving today. And also paste it in the chat so that you can pick it up from there as well. So this is the problem that is being presented to you. What you're being told is that you are, let's say, running a company and you make two types of products, cars and dolls, for example. And to make these two types of products, you need raw materials R1 and R2. Okay. So for each car, I require 6 units of R1 and 4 units of R2. And to make each doll, I require 1 unit of R1 and 2 units of R2. And when I sell a car, I will make a profit of 5 rupees. And when I sell a doll, I will make a profit of 4 rupees. You are being told that you have 24 units of R1 available with you and 6 units of R2 available with you. So given these resource availabilities, given these resource requirements for the two products, the question is, how many cars and how many dolls should I produce so that I maximize my profit? And we are going to assume that everything that you produce is going to be sold. All right. So this is the problem that we will be solving. Right now. So for any, if you take any, this is an optimization problem because we want to optimally use the resources. And for any optimization problem, there are going to be 3 pieces of information. What are those 3 pieces of information? Can someone tell me? What are the 3 pieces of information that is required in any optimization problem?
What's the decision variable?
Objective.
Pardon me, one person at a time, please.
Well, objective function.
Okay, you're going to have an objective function.
Input.
Decision variables.
You're going to have the decision variables.
Constraints.
And then you have the constraints. So these are the 3 things that are required for creating an any optimization problem, any LP formulation, linear programming formulation. The first is always the decision variable. Why? Because only if you have the decision variable, you can write the objective function. And only if you have the decision variables, you can then write the constraints. So always the first thing is the decision variable. Then what is it that you want to do? And finally, what are the constraints on it? What are the restrictions for determining these decision variables? Those are the 3 pieces. Okay. So for our problem, what is a decision variable? Can you tell me? There are going to be 2 decision variables. What are they going to be?
R1, R2.
No. R1 and R2 are, so what is a decision variable? It is what you want to find out. So what do you want to find out in these 2 problems? In this particular problem that you
okay,
have.
number of dolls and cars.
So number of dolls that I want to make and number of cars that I want to make. That is what I'm going to decide upon. So that would be my decision variable. So x1 would be number of cars that I'm going to make, and x2 is going to be number of dolls that I'm going to make. It does not matter. You can have x1 as number of dolls, x2 as number of cars. That has no impact. So that is going to be the decision variables for you. Okay. So what is the objective? What is my goal when I find the number of cars and number of dolls? What is my goal? That is going to be my objective function. What do I want to do?
Total number of cars and dolls.
So that is going to be what I'm going to find. So I
Yes.
want to find the number of cars that I must produce and the number of dolls that I must produce. I must find this with a goal of what? What is my goal?
Can you show up the question once again?
Yeah.
Maximize the profit.
Exactly. So my goal is going
Yes.
to be to maximize the profit. So that is going to be my goal. So I want to maximize the profit, right? So if I want to write a maximization of profit, what should I do? What is profit for me first? In this problem again, what is profit? What is the profit that I make?
Rupees
said-
4 for every doll and rupees 5
Rupees 5 for every car. So if I make one car, I make a profit of 5. And if I make one doll, I make an additional profit of 4. So that is going to be what I get if I produce one car and one doll. So this into x1 and this into x2 is the profit that I will make when I make x1 cars and x2 dolls. All right, everyone with me so far?
Yes, yes.
And I want to maximize this guy. So that is going to be my objective function. So maximize 5x1 plus 4x2. And usually what they do is they call this as Z. Z is usual notation for the objective function. So Z would be equal to maximize 5x1 plus 4x2. That is going to be the objective function. Then comes the third piece. Now I can, if I want to maximize this, I can say I want to produce 10,000 cars, 10,000 dolls, right? Random numbers I can do. But that is not possible for me because I have certain restrictions that I have to impose on this problem.
Constraints.
Which are the constraints, exactly. So the constraints basically impose the physical restrictions on your problem. So anything in the real world that is going to impact your x1 and x2, that would be captured in the constraints of your problem. So what are the constraints here for me? What are the constraints here for me? Tell it to me in words, then we will write it in.
6 units of R1 and 4 units of R2 for car.
For a car is okay, but yeah, you have given me the equation, Vijay Anand, but what is the physical meaning of that equation is what I'm trying to ask you first.
The raw material available.
So the amount of raw
Available
materials
quantities may be the constant.
Exactly.
24 units of R1 or 6 units of R2.
1 second.
We need to we have only 24 R1 resources available, 6 R2 resources are available. We have to work with that constraint to maximize the profit.
You have to work with the constraint to maximize the profit. Exactly. Someone just pointed this out. Yeah, TS. Okay. Constraints. Right. So my constraints are I have only 24 units of R1 and 6 units of R2 to produce my cars. All right. So my constraints come from the resources that I have. So the resource availability basically imposes the constraints for my model. So what is the available resource? I have R1, I have 24 units. And R2, I have how much? R2, I have 6 units. So R2 is going to be 6 units. So that is the constraint for me. So I have only 24 units and 6 units. So what does that mean? So for every car that I produce, I need 5. For every car that I produce, right? I need 6 units of R1 and 4 units of R2. So what does that mean? When I produce one car, I need 6 units of R1 and 4 units of R2. Okay. Similarly, when I produce every doll, Let's say I produce one doll and one car. I need 6 units of R1 and 4 units of R1 for the doll. And I similarly need 1 unit of R1, 1 unit of R1 and 2 units of R2 for a doll. Correct? This is for one car and one doll. But I'm going to make X1 cars and X2 dolls. So what does that mean? 6 times X1 plus 4 times X2 must be less than or equal to the amount of resource 1 available, which is 24. And 1 times X1 plus 2 times X2 must be less than or equal to the amount of units available for resource 2, which is 6. Everyone with me so far?
So please repeat this one.
Okay. So I have 24 units of R1. And every time I produce one car, I would use 6 units of R1. And every time I produce one doll, I will use 4 units of R1 for the doll. Right?
Yes.
Each car requires 6 units of R1 and 4 units.
So 1 unit of R1.
1 second.
But sir, for
That I write. Each car requires 6 units of R1 and 4 units of R2. Each doll requires 1 unit of R1 and 2 units of R2. Okay. 1 second. I think I wrote the numbers wrong. Each car requires 6 units of R1 and 4 units of R2. Okay. Right. So each car requires 6 units of R1 and 4 units of R2. And each doll requires, 1 second, I'll just come to it. I'll just write it down so that it's clear over here. 1 unit and 2 units. Okay. So what happens is I have 24 units of R1. All right. So when I have 24 units of R1, if I produce one car, I will consume 6 units. If I produce one doll, I will consume 1 unit. So,
but sir, X1 is the number of cars. No?
X1 is the number of cars. Yes. So
6 unit is required for 6
For
unit
one
R1 is required.
6 units of R1 is required for one car.
But you have written like 6 car into 6 into X1 means
Number
6.
of cars. Correct. So
6 into number of
if I
cars.
produce X1 number of cars, I will use X1 into 6, right? Of R1.
Yeah.
One car requires 6 units. So if I produce X1 cars, I need 6 into X1 units, right?
Okay. Okay.
Correct? So that is what this is. So I need 6 into X1 units for producing X1 cars. Similarly, I need 1 into X2 units for producing X2 number of dolls. So this total should be less than or equal to what is available to me, which is 24.
So this 6 and 1 should correspond to R1 only, right?
This 6 and 1 should correspond to R1. Yes.
Yes, that was the, yeah.
So here 6 units of R1, 1 units of R1. So 6 and 1.
So resource wise, we have to write the constraints for
Exactly.
one for R1 and next for the R2.
Next for R2. So
Yeah.
this is the resource constraint for R1. So this is the resource constraint for R1 and this is for R2. Okay? Everyone with me so far?
Got it.
Yes, sir.
Then these two are with respect to the resources. Then I have a constraint on the variable. Can I produce negative number of cars? Can I produce, let's say, minus 5 cars so that I can use the resource extra? I cannot. So both X1 and X2 have the property that they must be positive or they must be 0. So the non-negativity constraint comes into picture. So I will make sure that the number of cars that I produce and the number of dolls that I produce are either 0 or some positive number. They will not be less than 0. So that is the non-negativity constraint. Okay?
Yes.
So these are the constraints for my model. So now if I solve this problem, I'm not going into the solving of the problem. You can solve it in Excel. But this is how you formulate this particular small problem as a linear program where you now find out, if you solve, you will find out the number of cars x1 and the number of dolls x2. This is found. Why? This is because this is the optimal number that maximize my profit. Okay. So if I now solve the problem, I will find x1 and x2. That those values will be the optimum number of cars and the optimum number of dolls given this resource constraint that is going to help me maximize my profit. All right.
Right.
Everyone with me so far? Any doubts till now?
No, sir. Can we solve it manually also?
You can solve it manually. You can use it. You can use a method called simplex to solve
Yes,
this.
yes.
But I don't think that is in scope for you guys for our course. So we are
Yeah.
only looking at formulation and Excel-based solving. So this is the formulation for this problem. And why is this called the primal? And this formulation is called the primal. And it is the primal because the problem in its nutshell was focusing on the number of cars and number of dolls that I want to produce. Since this is a formulation where the decision variables are itself the number of cars and number of dolls that I'm going to produce, the formulation is the primal version of this problem. Okay?
Yes. Sir.
Got it? Everyone clear? Okay.
Would you mind repeating the last statement once again? Why
The
would you
last
call it?
statement is, this is called the primal formulation because the decision variables are directly giving me the values of interest for my goal.
Okay.
Right? Since I'm directly getting, if I solve, I'm directly getting the number of cars that I should produce, number of dolls that I should produce, and that is going to be the maximum profit. I'm calling this the primal formulation.
Fair enough.
And you will understand the difference once I do the dual.
Okay.
Okay. So this is the primal version of it. Now comes the dual. So what I'm going to do is the lecture by Srivatsa, the tutorial by Srivatsa, that is in fact one of the most appreciated tutorials across all courses in the BS program. All right, it's actually very, very clear. So what I'm going to do is, I am not going to go into the intricacies of the dual, but I'm going to tell you the most shortest way that he talks about in the video. Also towards the end he does that. I am going to highlight on that. How do you, given a primal formulation, how do you immediately convert to a dual and why it's called the dual? That is going to be the focus of my lecture. Okay.
So 1 minute before you go for the formulation of the dual, can you explain, sir, that overall objective is, what is the overall objective to do this dual thing, and what
is the reason for going for a dual? Is it?
Yeah. Yes.
Okay. So
What benefit?
Usually the dual is used when you have a lot of decision variables, but very few constraints.
Yes.
Okay. So in that case, what will happen is, in the dual formulation, you will get very few decision variables and a lot of constraints, which is easier to solve.
Yeah, it gets swapped. I mean,
It gets swapped. So
the constraints, number of constraints.
The constraints are, in fact, I should, based on your problem, one would solve faster than the other. That is why you will actually go for a dual instead of a primal. Because from there I can actually get the values for my primal as well, right?
Yes.
So that is the reason. That is why you have a dual formulation. In an LP setting, you might end up with a large number of decision variables, but very few constraints. Then what you will do is you will immediately convert it, saying I will have a large number of constraints, but very few decision variables, so that I can solve the problem faster.
Okay, the constraints will impact on the faster solution.
Yeah, I have lesser this thing, no?
Yes.
Lesser bounds.
Yes.
Or I have more. That also depends. That also depends to a certain extent. You can swap the problem. That is the entire thing. If a problem which has a lot of constraints is taking a lot of time to solve, then I will go in for a lot of decision variables and reduce the constraints. That is a scenario-based based issue, but that is what it is. That is the purpose of a dual. Ultimately, yeah, I can reduce the time for solving my problem.
Okay.
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 Any other questions? Super. Then what I will do is, I will tell you, like we did for this thing, like we did in the logistic regression, the best way to form a confusion matrix and everything else gets solved. Similarly, how do you formulate a dual given a primal? That is going to be the focus for me. So what I want to do is, the easiest method would be to convert of any primal formulation to the standard form. So what is a standard form? The standard form of a primal is basically going to have a maximization objective. All constraints has less than or equal to. All constraints of the model are less than or equal to, and all decision variables are greater than or equal to 0. Okay, just like we have here.
The objective will also be same.
Pardon me?
Sir, in primal, if it is maximized, maximizing.
No, I am telling, for getting a dual, you must first convert the primal to a standard form. So before you start a dual, step 1 is convert primal to the standard form. And what is that standard form? It should have a maximization objective. All the constraints should be less than or equal to constraints, and all decision variables must be greater than or equal to 0, just like the formulation that we have here. This is a standard formulation. Okay, standard form of the formulation for the primal. Okay.
And constraint for constraints that is equal to constraint?
Less than or equal to?
No, for equal to constraints. There may be some equal to constraint also.
Yes, I will come to that in a minute.
Okay.
I will come to that in a minute. Okay. So this is the standard form. So now comes the question of how do you get an objective to be, let's say the objective was maximization. So now let's say exception cases. If the primal had a minimization objective, then to convert it to maximum, multiply it with a negative sign. Okay. So for example, let's say you had minimize 4x1 plus 3x2 plus 7x3. This was your, for example, was your primal objective. Then this would become a maximization function if I say maximize minus 4x1 minus 3x2 minus 7x3. So that is how you will convert a primal's minimization objective to a primal's maximization objective. Fine? All of you with me so far?
Yes, sir.
Okay. Then comes the second. So the constraints can either be less than or can either be greater than or equal to or equal to. Correct? So when they are greater than or equal to, you do the same technique. When greater than or equal to change it to less than or equal to, what you do is you multiply by negative sign. An example for that. Let's say I have a constraint 4x1 plus 5x2 plus 7x3 plus 9x4 is going to be greater than or equal to 10. If this is my constraint, then what I will do is I will multiply this with a negative sign. So minus 4x1 minus 5x2 minus 7x3 minus 9x4 should be less than or equal to minus 10. That is all. So this is how I will convert a greater than or equal to constraint to a less than or equal to constraint. Okay. Any questions so far? No. Then what I do next?
So we have to follow both the things together. We need to multiply by -1 and less than equal to greater than equal to will be converted.
No, that
to
depends
less.
on your scenario, no?
Okay.
If I have a formulation where I have an objective which is minus, objective is minimum, then convert it to maximum, I'll multiply by -1. If I have a constraint which is greater than or equal to, then to convert it to less than or equal to, I'll multiply by minus.
And if it is already less than equal to minus.
No need to do anything, no. Because
Okay.
that is already in the standard form of less than or equal to.
Okay, got it. Thanks.
So we don't have to do anything. Okay. Now comes the question of what if I have an equal to constraint. So when the constraint is equal to, okay. So for example, let's say I have a constraint like 4x1 plus 5x2 plus 7x3 plus 9x4 equal to 10. If this is the constraint that I have, then to convert it to standard form, I must follow a two-step procedure. So what should I do? First, I would write this as two constraints. What does that mean? 4x1 plus 5x2 plus 7x3 plus 9x4 must be less than or equal to 10, and 4x1 plus 5x2 plus 7x3 plus 9x4 must be greater than or equal to 10. So this one constraint is now split into two constraints. And these two basically mean the same. Only for one value where they are equal to, they will match. Else they will not match. So this is now converted into two constraints. Now what do I have? I have ended up with a new greater than or equal to constraint. So for that greater than or equal to constraint, I must convert it to a less than or equal to constraint. So how will I do that? So in step 2, the second step, what I would do is I would multiply this by a -1. So I will have 4x1 plus 5x2 plus 7x3 plus 9x4 less than or equal to 10. This guy will just come. For this person, I will multiply by minus. I'll apply the previous scenario. So I will multiply by a negative sign. So what it will happen? 4x1 minus 5x2 minus 7x3 minus 9x4 is less than or equal to minus 10. So an equal to constraint is now converted into two less than or equal to constraints of the standard form, and I've got all my constraints in the standard form of less than or equal to. Okay, everyone clear up to this point?
Right.
Okay. So the final one, all addition variables greater than or equal to 0. What I will do is I will talk about one scenario later on. Right now, let's assume that all addition variables are greater than or equal to 0. Okay. I will talk about unrestricted variables in a minute, but that is after I tell you the shortcut to formulate a standard formula. This thing, so that it's become much more clear. Fine. Okay. So with that being said, I hope all of you have this formulation. so that I don't have to come back here. I will start formulating this as a dual. Okay. All right. So when I'm formulating a dual, I will follow, well, let's say the primal is in the standard form. Then I will follow this procedure. The first thing that I will do is the number of decision variables in the dual is equal to the number of constraints in the primal. So for my example formulation, the cars and dogs formulation, how many constraints were there? How many constraints were there?
2.
I have
Two.
two constraints. So one for resource 1, the other for resource 2. So I will have two decision variables in the dual as there were two constraints in the primal. And what are those decision variables? Let's call them y1 and y2. What would those represent? So in the previous one, we said x1 going to represent the number of cars produced. Y1 would x2 will represent the number of dogs produced. In the
Resources.
dual, okay, so what is the actual meaning of that? It's going to be in your path resources. So what does y1 mean? What would be the interpretation of y1?
Maximum.
Not profit.
No,
What would be the interpretation?
maximum resource available.
Not maximum resource available, no. Cost of resource 1, okay, in another sense.
Minimize the cost.
Minimize the
Proportion
No, that is
of,
going to
proportion of
be the objective. That is going to be the objective. So someone
proportion
actually,
of variable 1.
proportion of variable 1. No, someone actually put it in the chat. It's going to be the cost. So what is the cost of using R1? That is going to be your Y1, right? The cost of using 1 unit of R1. Cost of using 1 unit of R1. That is going to be your this thing. Your decision variable here.
Okay, sorry, I should have said it differently. Sorry, just correct me, I may be mistaken again. Proportion of constraint 1. Not variable 1, but proportion of constraint 1. Because when I say y1, it is the first equation that I'll be multiplying it and then getting it, right?
Correct. But
yeah.
what proportion? Proportion of what? When you say proportion, it could mean a lot of things. It could be quantity, it could be cost, it could be anything. Here it is cost.
Right.
Cost
Okay.
of unit using 1 unit of resource 1. That is going to be my y1. Similarly, y2 is going to be cost of using 1 unit of R2, which is resource 2.
So you are making this conclusion of decision variable from the constraints.
From the constraints, yes. So y1 and y2
So
would
how
be
how it is interpreting the cost thing? The constraints, how we can interpret the cost from those constraints?
that would be clear once we look at the objective
Yeah.
function.
Okay.
All right.
Okay.
So that is going to be your y1 and y2 decision variables. Next comes the objective. So what could be the objective? Since I'm looking at resources, my objective here is going to be the opposite, right? So if I
Minimize the resources.
minimize the cost associated with those resources. Yeah. So the brute force method is if the primal is maximized, then the dual is minimized. Okay. And if I have a minimization objective, there it was profit maximization. Here, I want to minimize the cost associated with my resources, right? Cost associated with consuming resources. So it's going to be minimize the cost of consuming the resource.
1 unit of resource.
Minimize the
Okay.
cost of consuming my resource. Yes.
Okay.
Not 1 unit of resource. That will come when you write the formulation. So you are going to minimize. So if I consume 1 unit of resource, I will incur a cost of y1. If I consume 1 unit of resource 2, I will incur a cost of y2. And how much will I consume? I can consume a maximum of 24 and I can consume a maximum of 6. Correct? So if I consume 1 unit of y1, I will have 24. I will have a cost of y1. So if I consume 24, that is going to be 24 into y1 plus 6 into y2. So now reduce this cost of consuming. That is your goal. Right?
Okay.
All right. In the previous one, it was reduce the number of units, maximize the number of units produced. Here it gets ulta and tells you reduce the cost of your resource.
First, we have introduced this new decision variable y1 and y2.
Yes, y1 and y2,
and that we have said that y1 is the cost of using 1 unit of R1.
Yes.
And then we are minimizing it. So
Yes.
it depends on us what to introduce the decision as a decision variable.
No, decision variable is always going to be the constraints only, no? So
No, I'm
the
not.
decision variable is going to be the number. So since the decision variables in the dual is the number of constraints in the primal, there
Yes.
are always going to be one constraint for each, one decision variable for each constraint.
So I'm saying that y1 we have said that it is cost, but it could be anything else also.
How can
But
it be
it's
anything else?
not here. In some different question could be anything else also.
How can it be anything else in any other question? It's always a dual, no? In the dual, that's always going to be
No,
a
no,
cost
sir.
associated with that resource.
This
only, no?
Yes, sir. But this y1 and y2 are the new decision variables which we have introduced. It's not mentioned in the question, right?
It's not meant that, okay, that is why it's called a dual, but anyhow,
Yes.
but that is always going to be cost.
Yeah, in some
That
sense.
is always going to be a cost, yes. No matter what problem you solve, it's always going to be the cost for that particular constraint.
So it's just a convention. For example, x1 and x2 was also not given in the question. So it's a convention to name them as x1 in the primal, and generally in dual you will call it as y.
Yeah, that's okay.
Okay. So minimize 24 into y1 plus 6 into y2. Okay. Where does this 24 and 6 come from is the question. So again, I'm just going to do that. Once again, I'll write the formulation, then I will try to make it this thing simpler. So the 24 and the coefficients, these are called coefficients. The 24 and 6, this is the RHS of constraint 1. And this is the RHS of constraint 2. So in a brute force method, if y1 corresponds to the constraint 1, then the coefficient of that in the dual is going to be the RHS of that constraint. y2 is the variable for constraint 2. Then the RHS of constraint 2 becomes the coefficient of the dual's objective function. Okay?
Yes.
Right. So that is the objective. Then comes the constraints of the dual. Here, the number of constraints in the dual is equal to the number of decision variables in the primal. Okay, so that is the by default. So how many decision variables I had? I had 2 decision variables, x1 and x2. So I'm going to have 2 constraints. I'm going to have constraint 1 and I'm going to have constraint 2. Okay, so what is constraint 1? Constraint 1 is going to correspond to the decision variable 1. Okay, so what was my decision variable 1? It was basically the number of cars that I'm going to produce. So what was the constraint? I can produce 6 cars or I could produce one car with 6 units of resource 1, and I could produce I could produce one car with 6 units for constraint 1, and I could produce how to say this more easier. Okay, for constraint 1, okay. For every car that I produce, I would make a profit of 5. Okay. So for every car that I produce, I would make a profit of 5. And for every doll that I produce, I will make a profit of 4. All right. Making sense? This is the RHS. The coefficients of variables in the objective function of the primal become the RHS for my constraint. So this was the coefficient for the first variable x1, and this was the coefficient for the second variable x2. So I will put 5 and 4. Okay? Yes, no.
Yes,
I will
sir.
tell you why the greater than or equal to in a minute. So I would okay. So I will make this. I will only go for buying resources. I will only go for using resources, spending on my resources, only if they are going to help me go beyond and above the cost of those, beyond and above the profit of x1 and x2. So what I should do is, I'm going to have y1, I'm going to have y2. So when I will buy y1, I will buy y1 only when it is going to increase my 5, and I'll buy y2 only when it's going to increase above my 5. And the unit increase for every y1 is going to be 6, which is going to be this guy.
And 4.
6 and 4, which is going to be for x2, which is going to be for the second resource. So I can go beyond the value of 5 when if I buy y2 4 for every one y2 that I buy, I can add 4 units. So if I buy 2, I will go beyond 5. Similarly, for every 1 by 1, I can go beyond 6. I can go up to 6. If I buy 2, I can go up to 12, so on and so forth. I think I'm making it a bit complicated over here, but any doubts? The number of constraints is in the dual is going to be the number of decision variables in primal. So I'm having 2 constraints. The RHS of these constraints are going to be the coefficients of the primal, so 5 and 4. And
so this 5 and 4 is corresponding to the number of x1 and x2.
No, the corresponding to the coefficient of x1 and x2 in the objective function.
Okay, and there it was 5 corresponding to the profit.
That was corresponding to the profit for x1. So yes. I will buy resources only if I can make more profit than this 5. That is why the greater than or equal to.
Yeah, there is 5 units of profit on x1 and 4 units of profit on x2.
X2. So I will start buying the resource required for x1, which is y1 and y2, only if both of them together are going to increase beyond 5.
Okay.
Similarly, I would buy the resources of y1 and y2 for 4 only if they go beyond 4. For x2, if they go beyond 4. And what is going to be the coefficient of these two? In this
1 and 2. 1 and 2.
1 and 2, which is going to be the variables of this 1 and 2 for x2. All right. I think you might got more confused than more clarity. Okay. Let me do one thing. All right. Let me do one thing. Let me just finish this, and then I'll give you the easiest way to remember all of it. Okay.
Okay.
So 1 into y2 plus 2 into y2, and obviously the costs cannot be negative, so y1 and y2 must be greater than or equal to 0. Okay. So this becomes the dual formulation for my primal. Fair enough? Okay.
So,
So let's
can
go
we
ahead.
directly do it by looking at the equations?
Yes,
Because it seems
that is
like-
what I'm coming to right now. That is what I'm coming to. So once you convert a primal to the standard form, okay? So once you have a primal in the standard form, what will you have? You will have an objective of maximizing Z, which is going to be summation over Cj into Xj, right? J is equal to 1 to n. I'm going to have n variables, and each is going to have a profit value of Cj. So Cj into Xj is what I want to maximize. And this is going to be subjected to the constraints basically is what it is going to be summation over j is equal to 1 to n sum aij into xj. This is going to be of the form less than or equal to sum bi, where I is going to be equal to 1 to n. There are n constraints. So in this formulation, there are this is going to be 1 to m. So there are going to be n decision variables and m constraints. Everyone with me so far? When I write it like in this form, I'm going to have n decision variables, which is going to be the subscript for j is equal to 1 to n, and there are going to be m constraints. Okay? Yes, no.
Yep.
I got 1 thumbs up. I got 2 thumbs up. Okay.
Yes, sir.
All right. Okay. And all my xj's are going to be greater than or equal to 0. That is what I'm going to instruct. Okay? For all j. This is the standard form. So if I have to convert this standard form to a dual, this standard form, if I want to convert to a dual, all I have to do is, if there is a maximize, I would put a minimize. If there is a z, here the standard notation is w. If there is a z, it is a w. What is it going to be equal to? Summation over j would now be replaced by I. Summation over I is equal to 1 to m. This Cj would be replaced by Bi, and this Xj would be replaced by Yi. Okay? X would be turned to Y, and C would be converted to B. And what would my constraints now be? The constraint would now be this J, right? So that will be converted to I. So summation over I, whenever I do I, it's going to be 1 to m. So 1 to m. This Aij would be the same. The only difference is this was summed up over j. Now it is going to be summed up over the first suffix, which is going to be I. Okay? Summation over Aij, that does not change. Instead of x, wherever there is an xi, xj, I would substitute it with a yi. And wherever there is a bi, I would substitute it with a cj. And I would write j is equal to 1 to n. And obviously, yi is going to be greater than or equal to 0 for all I. So what has happened? I would have I variables, decision variables, and so I would have I is 1 to m, right? So I would have m decision variables and n constraints. So that is what this is. So I had m decision variables and m constraints. I'm now going to have m decision variables and n constraints. That is the dual. Okay? Did this make life simpler or?
So, sir.
For second one, it should be greater than or equal to 0, no? A,
Oh, sorry.
A,
Yeah,
Y,
yeah, sorry. No. This is greater than or equal to 0. Oh, sorry, this is my bad. This is less than or equal to, it will become a greater than or equal to Cj. Yeah. My bad. Yeah. Okay. So what I will do is I will ulta everything off in the dual. Maximization would become equal to minimum. Z would be replaced with W. Cj would be replaced with Bi. Xj would be replaced with Yi. So if there is a suffix j, I would replace it with I. If there is a suffix I would replace it with the j. So here I had summation over j is equal to 1 to n. So here I will replace it the same summation I is equal to 1 to m. Aij does not change. It will still be Aij. Since the summation changes, the variable, the coefficient will not change. Xj would now become Yi. The less than or equal to will now become greater than or equal to. B would be replaced with C. And since I'm going from y is equal to 1 to m, here I'll go j is equal to 1 to n. And since my variables must be greater than or equal to 0, that does not change. My variable must be greater than or equal to 0. Here it was for j variables. Here it is going to be for I variables. Okay. So this is the dual formulation for a primal, the brute force method to solve it. Okay. Any questions?
Sir, in the constraint equation for the dual, the limit is from I to n, no? Will it be m or n?
M, no.
Because in the
sorry, it will be
primal,
M, no. It will be M. Because I have M constraints. So I should have M, this thing, coefficients here.
in the primal, there are n in the decision variable. There are n
Correct. That is
total
J.
number of variables.
That is
Yeah.
J. So
Yeah.
I am putting it
So,
here now.
in
For J is equal to 1 to M. Now let's apply that to our example problem. What was our example problem? Our example problem was maximize Z is equal to what was it? 5x1 plus 4x2. And the constraint was what were the constraints? 6x1 plus x2 less than or equal to 24. 4x1 plus 2x2 less than or equal to 6. I believe this was the thing, correct? Yes, no? Yeah, 2x1 is less
Yes,
than
sir.
this thing. This was the constraint. And x1, x2 greater than or equal to 0. So if I have to write this in this form, in a matrix form, right? So what did I do? My C1 is equal to 5, C2 is equal to 4, and A11 is equal to 6, A12 is equal to 2, A21 is equal to 4, A22 is equal to 2. Correct? This is what it is. And B1 is equal to 24.
A12 is equals to 1, I think.
Oh, sorry, A12 is equal to 1, correct. Is this number 1? A12 is equal to 1, A21 is equal to 4, A22 is equal to 2. Okay? B1 is equal to 24, B2 is equal to 6. Fine? Everyone got this? How I converted this guy to these numbers? Any questions? No questions? Super. Now let's apply this rule to get the dual. So what am I doing? I am putting a minimization. I am doing B can be 1. What is my M? Okay, that also I'll write it down. How many constraints do I have? I have constraint number 1, constraint number 2. So M is equal to 1 and 2. And N is equal to, I have two variables, 1 and 2. Okay? So write that. So minimize my W is equal to B1 into Y1 plus V2 into Y2. What was that? That was 24 into Y1 plus 6 into Y2. Then what was my constraints? My constraint was Aij summed up over I. So I have, for my first constraint, when j is equal to 1, my first constraint is going to look like A11 into Y1 plus A21 into Y1. Sorry, A21 into Y2 must be greater than or equal to j is 1. So C1. What is the second constraint? J is equal to 2. So over there, I have A12 into Y1 plus A22 into Y2. Sorry. J is equal to, yeah, correct. A22 into Y2 must be greater than or equal to C2. Correct? So what does that become now? It becomes 6. I share a jam file with me. Okay. So 6y1 plus a21, which is 4. So 4y2 must be greater than or equal to c1, which is 5.
5.
Similarly, 1 a12, right? So 1y1 plus 2y2 must be greater than or equal to 4, which was the formulation that we did here. So that is this 6y1 plus 4y2 greater than or equal to 5. 1y1 plus 2y2 is greater than or equal to 4. Then we will have y1 and y2 greater than or equal to 0. Done. Okay. So now the same technique will help you convert. So what you should do is, once you are given a primal, you should first convert it to the standard form. Once you have converted it into standard form, write down the C1, C2, C3, all of these, and just use this method to convert the equation and get it. All right. Any doubts or questions?
Not necessarily a question, but trying to my own understanding of what you just mentioned. So if you want to maximize a function, you have to minimize the constraints or the effect of the constraints. If you have to minimize,
obviously, no, it's upper bound.
right.
That's
So if
just
you,
upper
the
bound.
opposite holds for if you want to minimize the function, then you have to maximize the constraint. So that settles that part of the story.
Yeah, it is a lower bound.
Okay, and that's the reason why we want all the constraints to be in the standard form before we go from primal or
That
dual.
is one reason, and the second reason is once you start doing primal, duals, all of those stuff, you'll automatically be able to do it even without the standard form. That comes with practice. Even if it's not in the standard form, you will be able to do it. But it's always better to convert to a standard form than do it. You'll have a very clear understanding of what is what. Yeah, this is a very, I don't think you would have studied optimization and formulations anywhere else in your BS program, correct?
I believe I did that in my engineering OR. I'm just
Engineering
trying to
OR is okay, but in this BS program we are talking about.
No.
No, right? So that is why we are keeping it at this level. Usually there's a separate course where you first start off with understanding formulations, what is addition variable, what is the constraint, so on and so forth. Then you will start formulating a set of problems. Then you will convert it to a standard form. Then you will do the dual. That in itself is a separate course, right? And what is the integer program, why it's not, so on and so forth. That and all we are not getting into. We are just telling you a simple way to convert it as an introductory piece.
Okay, and one more point. Sorry to interrupt your train of thought. Just want to get my points all cleared. If there is an equal sign in the constraint, you want that to be written, or rather, we want that to be written in both greater than or equal to and less than or equal to, or greater than and less than.
Yes.
Which one is it? Greater than and less than, or
you have to write it in two, because in your standard form, everything should be has a less than or equal to constraint. Correct?
Right.
So an equal to constraint is not a standard form. So when will a constraint be equal to? I can write it as an equal to constraint when I write it as two constraints which are less than or equal to and greater than or equal to.
Right.
Then I convert that greater than or equal to constraint to a less than or equal to constraint. That is the procedure. It's a two-step procedure.
Okay, this way I'll be actually increasing the constraint automatically by one number.
Automatically increasing the constraint, exactly.
So it may not always be beneficial also.
What do you mean by it may not always be beneficial?
When
You
I
anyhow
say,
need that variable,
when I am converting it to a dual.
No, if your problem is not converging, if it has a lot of decision variables, then you are just adding 2 more constraints as compared to the number of decision variables. Let's say it
When
has
I
10 decision variables and 2 constraints. Both are equal to constraints.
Correct.
Then that would basically become a 4 variable problem.
Right. Now, if I actually have 2 or 3 constraints which are all equal to, and then it is better to solve it in primal rather than going into dual, because my number of variables will increase in that, isn't it?
The thing is, an equal to constraint is called a binding constraint in its nature. They have to be equal to. Solving an equal to constraint is very difficult. So it's usually better to convert an equal to constraint to these constraints and solve. It indirectly means equal to, but the binding constraint is very difficult to solve.
Okay.
In a problem, in an optimization problem.
Okay.
That is why you always prefer a less than or equal to constraint or a greater than or equal to constraint any day.
Sir, I hope that you will upload the video in the channel.
It is by default getting uploaded, Baba. There are very few instances where it does not get uploaded.
On this point of equal to, once again, it's binding constraint because all the variables need to be, a condition is being imposed on all the variables.
The condition that combination should be equal to 10 is being imposed. And finding a combination that is equal to 10 might be difficult. Might be difficult. It may not be always the case, but it might be difficult.
Okay, okay.
You might get usually when you solve a equal to binding constraint problem, you might end up with infeasibilities as a solution. Because of this binding constraint, if there is an infeasible solution, the first thing that we will go check is if there is a binding constraint, try to make it a non-binding constraint, so that you can solve for a better you can solve for the problem. So that is why equal to is now preferred.
Okay, okay.
Again, these are all OR concepts. We are not getting into those.
Okay. Sorry, curiosity. It's a long time since I've done my engineering, so trying to.
Okay. PA question 5. 1 second. This assignment. Question 3, 4, 5. If you find that the second derivative of RP with respect to P, what do you conclude? This guy, revenue maximization. Hey, this is a direct theory question. You should not ask me. You should check the video. So week 9. Wow. Okay. Theory questions. Okay. Week 9. Oh, DEA. We will do a separate session for DEA. Then we will cover. Then we will answer. We will do this next week. We will do a separate session for both because we want to cover both weeks 8 and week 9 in DEA. We will do a separate session for that, Ayush.
So the reason why we are not doing this today is because most of you might not have seen the video. So I request everybody to watch the DEA video and come next week. We'll also solve these practice assignment problems. Definitely there will be one.
No problem. Actually, I have seen and I tried.
Okay, sure.
But maybe I'll post it on Discourse. So
yeah, sure.
Yeah, no problem.
So we will cover. So we are planning for 2 more sessions for sure. One is exclusively for DEA. The other is for conjoint analysis. All right. So that would actually be very convenient because 2 weeks of DEA, we will start that next week. And conjoints second week would have also been released next week. So The week after that, we'll do conjoint analysis, and then we will wrap our this thing. Okay, wrap up our courses.
Week 11 and 12.
Week 11 and 12 they will be releasing. No? Next week when we do DEA, week 11 would be released, and then the following week we'll do conjoint analysis where week 12 will be released. Week 12 is just an epilogue, so you just need week 10 and week 11 for conjoint. 8 and 9 are DEA. 10 and 11 are conjoint.
Okay.
So once we
So you will take it together, right?
We will take it together, so there's no confusion.
Okay.
So the only way you can get better with the primal and dual formulation is to practice a lot. For that, I had shared a link of a textbook, Operations Research by Professor G. Srinivasan from IIT Madras. In fact, I had done my OR under him. I would strongly recommend you to go through these textbooks and practice these primal dual formulations. And there are also lots of interesting case studies. If at all somebody wants to do a master's in OR or industrial engineering, computer science,
is it freely available because it is also in review?
No, I just shared the name of the textbook. You can buy it in Amazon or Flipkart.
The book is only around 250 rupees, man.
Yes,
and it's actually a holy grail. It's a holy grail. Really, there are few textbooks which everyone in OR would have done. For example, if you're a student who was registered for an OR, if you're an engineer who was mechanical engineering in particular, if you are doing OR course, everyone would have visited the NPTEL course by Professor G. Srinivasan. Everyone would have done that session. He's a beautiful teacher. So he would have
you said?
Professor G. Srinivasan from IIT Madras.
For what? For which course?
Operations research. Yeah, for operations research.
Okay.
Operations research in general. Every student in India from our time would have checked out Professor G. Srinivasan structures on NPTEL. So that is like a holy grail. And this textbook is by sir.
Okay. I will try for sure, sir. Thank you.
Okay, so this is what I had. There is one more concept called dual price. Okay, I believe if I take that, you might get a bit more confused. So dual price, you just check Shiva, you just check the tutorial video. After the DEA session next week, if you still have any questions, please feel free to ask. I will also be there. Okay. So we will cover this topic as many times as you want, primarily because this is the first time you are seeing an optimization formulation and a solution. So take time to sink it in. Any questions at any point in time, please feel free to post it in Discourse or come to us and ask in a live session, and we'll be happy to answer it. Okay.
So, sir, we will have one more in this week or next week only?
We are having a session next week on DEA.
Okay.
And at that time, if you have any questions on formulations of LP, you are free to ask. I'll also be there.
Okay. So next DEA session will be slightly shorter. So what I will do is I will share one case study on OR. Maybe you can try formulating and do the primal dual thing. We will discuss it next week as well.
Where will you share it?
I will share it via email or via announcements.
Means we have to check in the forums, you mean? Discourse?
I'll ask the admin people to send it to you.
You will get an announcement like we do, no?
That'll work.
Yeah,
so we'll send you an announcement.
Maybe you can put it on Discourse and you can pin it as well.
Okay, whichever is convenient. I'll try both.
Sure.
And I mean, like sending it to email, I would prefer that because Discourse.
Okay, sure. Because it gets lost.
Yeah, usually the hottest like. Okay. I have one more question. Maybe it is too dumb to ask this now.
No such thing as dumb questions. So please.
What exactly has operations research got to do with machine learning or data science? Is there a specific application where we have the opportunity of using this over there and get better results? Any example or something you might cite?
Malo, can I take it?
Absolutely. I was actually asking you to because you are from the industry.
Sure. So whatever we do with data, generally it is called analytics. So what you do in machine learning is generally called a predictive analytics because you are predicting something.
Correct.
All these OR based techniques are called prescriptive analytics. So because you're prescribing something. So in the example that Malo shared, he was telling what should be the optimal number of dolls and what should be the optimal number of cars that you have to make with the available resources. So here you are prescribing something. You say that if you produce X number of cars, X1 number of cars and X2 number of dolls, you're going to maximize your profit function and that is going to be optimal. So you are apparently prescribing something. So generally,
Right.
machine learning deals with predictive analytics and these kind of OR techniques. They are called prescriptive analytics. So this is a powerful combination. In industry, we use something called stacked models, where first we do some predictions. And on top of the predictions, we run the optimization algorithms. For example, let us say I'm going to forecast something. Let's say I'm going to forecast number of calls a call center is going to get. That is my forecasting.
Right.
That is number one. So if I say my call center is going to receive 100,000 calls tomorrow, I do need certain resources to handle those 100,000 calls.
Correct.
So next question would be, how many people do I require in the call center to attend those 100,000 calls?
Okay.
Number of people required to answer those 100,000 calls without getting abandoned. So you're solving two separate problems. Number one, you're first predicting something or forecasting something, forecasting the demand. That is the first problem. The second problem, in order to cater to your demand, what should be the optimal number of resources that are required in order to achieve your service levels and so on.
Okay.
These are called stacked models. These are very powerful in the industry.
STAT models or
Stacked, S-T-A-C-K, stacked models.
stacked models. Okay.
Yep.
Stacked models. Okay. Thank
But
you.
one is stacked over the above, right?
Okay. Okay.
And
Sir, 1 minute. So on what platforms we apply this for problem?
Generally, OR is a tool. You need to identify right use cases, business problems. And so OR, it is generally a static case where you make assumptions that you have only 5 resources, you have only 4 resources, everything, you are making certain assumptions there. It's a deterministic model. Whereas machine learning, it has a lot of uncertainties and so on. Whereas in OR, you don't deal with uncertainties.
Yes, yes.
So this is a tool and you need that expertise to identify use cases for using these tools. That comes with experience.
Okay.
okay, on that note, I will actually conclude with one thing, why this is called the dual for the primal. We said that this was the primal version of the problem, and that is the dual version. Why? Because this primal formulation, your decision variables directly addresses addresses the question of how many cars I should produce, how many dolls I should produce. Whereas through the dual, the question that you will be answering is how much amount of resource I optimally require, I must optimally buy, and from that you should basically go and tell how many cars I should produce, how many dolls I should produce. So that is why it is the dual. All right. So that is why that is called the dual, and this is the primal version of it. That is the dual version of it.
So now you converted primal to a dual. Similarly, you can also convert a dual into a primal. Which
the dual of a dual is a primal. Okay.
All
So
right.
this is what we had for today. Any other questions? We need to solve this problem to the term of just run the equations.
What we will be doing next in next session?
In the next session, it will be DEA, and then you can come back with any doubts that you have in the dual formulation.
Okay.
Okay. And with respect to the question of will you be asked to solve, solving is not in scope for you guys. You are using a tool to solve it. So solving is not in scope for the exam, but we will be asking you trick questions like the one that is there in the practice problem, where whatever constraint is binding in a primal, what will be the value of the decision variable in the dual, so on and so forth. Those kind of questions we'll be asking.
So when you say binding, it is equal to?
A constraint, it could be a look. What do I mean by that is, let's say I'm producing cars and this thing. Let's say I'm producing cars and dolls for maximization. What has become is resource 2, I'm completely utilizing it to 6. I have produced 4 plus 2, which is equal to 6.
Right.
Okay. So I've produced 1 car and 1 doll. Okay, for example. Then now this has become a binding constraint for me. It was originally not a binding constraint, but because of my solution, it has become binding. All right. For a binding constraint, the dual price, that is something that you can see, the dual price will be 0. And whatever value is for the dual price, that is going to be the particular decision variable's value in the dual. Like I said, if I talk to you about that right now, you will get even more confused because I've already confused you with the primal dual formulation. So what I will say is, when this is a binding constraint, what does that mean? I cannot say that I will not buy this amount of resource. I must buy all 6. Correct? So y1 would then be 6. Y2 would be, y2's value will then be 0. I cannot say I will not buy anything. I will have to buy all the 6. That is why it's a binding. So any binding constraint in the primal, the corresponding decision variable in the dual will be 0. Okay, like I said, do one thing.
There was a question that was there in quiz 2 papers of the past when you had asked as to one equation is already satisfied. One of the constraints is satisfied. What is the value of y2 is the question that was there.
Yeah, and that is 0.
Is it the one that you are actually referring to here?
Yes, I'm
now?
exactly referring to that. And in fact, there is also one question like this in your practice assignment.
Yeah.
Which week is this?
I think it is 8. I don't
dual is not 8. No, efficiency comparison. Data analysis is 8. This is this.
It was the first question, if I remember it right. It was the first question of that practice.
First question of week 5. The linear programming is week 5.
Yeah.
Implementing constraints. This question, right?
Yep.
A, B, C, the dual variables corresponding to constraint 1 is y1 and constraint 2 is y2. After solving, you find the primal and finding x1 star and x2 star. We find that x1 plus x2 is equal to C. We find that the first constraint is binding.
Yeah.
Like the same one like here, 2 plus 4, 4 plus 2, 6.
Yeah.
Then what is the y2? Y2 is obviously going to y2. What is the value of y2 star after solving corresponding to the second constraint, right?
Yeah.
So the value of a non-binding constraint, what did he do? Value of a non-binding constraint is 0. Sorry, I said the other way around, I believe. Value of a non-binding constraint is 0.
Yep.
That's what he's done. Yeah. X1 star plus x2 star is C, and dx1 plus ex2 is F. The value of a non-binding constraint becomes 0 because I cannot have, this is cost. No, correct. Sorry.
Right.
So this is a non-zero value. Non-zero y2. I made a mistake here, and this is y1 will be equal to 0 because it does not bind. If I produce 1, 6 plus 1, I'm getting 7, which is very much less than 24, which means that it is not binding. I do not have to spend on that resource. So that guy's value becomes 0 for me. And this guy's value becomes y2. I told it the other way around, sorry. That is the dual of a dual, he holds true.
Okay.
Yeah. So this is what it is. Correct. This is the question.
Yeah.
It becomes 0.
Okay.
I'm very tired. Sorry. Yeah.
It's okay. Thank you.
So the value of a decision variable when it's non-binding, value of the dual decision variable of a non-binding constraint is 0. All right. Final thing.
Yeah.
Like I said, I'll cover all of this again maybe in the next lecture after the dual price and what are their values.
Yeah.
Okay. Anything else? Dual of the dual is primal. How? Try and do it, you will get it. Try and solve it, you will get it. The dual of a dual becomes the primal. It is also explained in the last portion of the lecture, tutorial lecture. You can also verify that. And as an exercise for the same problem, I have created the dual for you. Just create the primal and see. Just create the dual of the dual, it will merge with the primal automatically.
Thank you very much, sir. I will take leave. Have a good night. Bye.
Okay, thank you, guys. Any other questions? All right. Then if there are no more questions, we wind up. We have 14 people on the call. When it drops down less than 7, we will also log off from the meeting.
Okay, sir. Good night.
Thank you. Good
Thank
night.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
So logging on, I'm going to stop recording.